basically we're figuring out how to tell if two triangles are similar. So we know that for something to be congruent, so congruent is opposite of similar. When stuff is said to be congruent, they are exactly the same. They're identical. So two identical figures are said to be congruent. But just because an object looks like it might be exactly the same, maybe they are, maybe they aren't, you can prove it through some of the postulates or theorems that we learn. And just like how we prove things are congruent, we can prove if they are similar as well. So today we're focusing on whether two figures are similar or not. There are postulates and theorems to help determine whether two figures are similar. So for things to be similar, there are some criteria that we learned previously. So let's look at some examples of these sets of triangles. Each set has similar triangles. So what are we noticing, say, about the first set? What's the same and what's different? The angles are all the same, right? So what you're noticing, you could say same angle measures. Even though one is clearly bigger than the other, they still have the same angle measures. Is that the same for this other set of triangles? Do they have the same angle measures? All right, yes, so I would say that again, same angle measures. So if they're similar triangles, they need to have the same angle measures. What would you say about their side lengths? Are they the same or different? All right, they're clearly different, but they are proportional. All right, remember that word, they are proportional. So if I did have side lengths, they would be to the same ratio. So you could say different but proportional side lengths. And that's true for both of them. So if you want to say the same thing as over here, I don't know if I can close this or not. You can just copy that on the next part as well. Same thing, different but proportional side lengths. Questions about that? All right, so that's really the only two criteria you need to prove that two triangles are similar. This we've already talked about, so I'm just going to kind of run through it. Just stop me if you have any questions. We have figure 1 shows triangle ABC that has been dilated by a scale factor of 2 to create DEF. So DEF is 2 times as big as ABC. You could show that or prove it by taking each coordinate of the original triangle. And just like we did with dilations, we multiplied each number by 2 in order to get our dilated triangle. And what we learned during the dilations lesson is that dilated shapes are always similar because they will always have the same angle measures and side lengths that are proportional to the original. Only thing I would highlight here really is the size of the original triangle changed, but the shape of the original figure has not changed. So the corresponding sides are proportional. questions? All right, now figure 2, we are now putting the smaller triangle, the pre-image, into the dilated one. Just showing you that the angle measures are the same. All right, so they have different side lengths, but they have the same angle measures. Questions about that? So same angle measures. Translating something, like putting it into the dilated image, is one technique of showing that they have the same angle measures. All right, the angles are congruent, but the side lengths are not. All right, it skips figure 3. Just don't worry about figure 3, I guess. Figure 4 shows you that angles A and D measure 45 degrees and angles B and E measure 95 degrees. So it's the corresponding angle that is the same on each triangle. All right, so the corresponding angles are congruent to each other. C and F are corresponding, but they're not labeled. We can figure out what those should measure to. All right, why am I able to figure that out? One of the theorems or postulates that we learned. We learned previously that all triangles, their angles add up to 180 degrees. So here we put all triangle angles, sorry, add up to 180 degrees. For a triangle. So if you have 2 out of the 3 angles, you can figure out what the missing one is. If you have maybe this one wasn't labeled, so I'm just going to kind of black it out, I can still figure out what angle F is because I know that E corresponds to B. If that wasn't already there, I could label it because it is labeled on the other triangle that's similar. Does that make sense? So I can figure out what F is even if I only have the other angle labeled. So figure out what angle F is, what angle C is. Usually I just do 180 minus whatever angles are there. Just type that all up into my calculator. All right, so what is that missing angle? All right, if you did it correctly, you should have gotten the missing angle is 40 degrees. All right, so angle C and angle F equal 40 degrees. All right, questions, comments? All right, so that leads us to this next postulate that we're going to talk about, which is called the angle-angle similarity postulate. The part that says what it says right here is the part I would highlight. So if 2 corresponding angles of 2 or more triangles are congruent, the triangles are similar. So even if I don't have a side label, even if one of the angles is missing, As long as I have two that are the same, they're on the corresponding and they're congruent, then I can automatically say that they are similar. All right, to prove that they're congruent, I would have to do like more stuff with like the sides and things like that, maybe the other angle, well, not the other angle, but the sides for sure. But just to prove that they're similar, you need to have two corresponding angles that are congruent. Questions about that? And just a side note, order is important when you talk about congruency. It's also important when you talk about similarity. Because saying that triangle ABC is similar to DEF. So triangle ABC is similar to triangle DEF would be the correct way of writing it, right? Because A corresponds with B and it goes first. B corresponds with E and it goes second. All right, so that it would be the correct way of writing it. If I mix up the order on one of these and not the other, then I'm showing that the different angles are similar when they're not. Questions? All right. Also, if you didn't realize, this little squiggly right here means similar. Kind of like a sideways S if you think about it. That means similar versus the congruent symbol. All right. Questions? So now determine whether or not two triangles are similar. So first one here on the left-hand side, remember the postulate says you need to have the corresponding angles to be congruent, and you need a minimum of 2. So first thing I would do is highlight or circle, star, identify my corresponding angles. What angle does A correspond to? Corresponds to F, I would agree. What angle does E correspond to? Good. And if I like tilt the other triangle, that does match up correctly. So are those first two triangles similar? Yes. All right, now let's look at these two. Any questions so far? Now it has, let's first identify our corresponding angles, even if they're not all labeled. What angle would correspond with angle A? Which one did you say? B, good. It's not labeled, but we can figure that out here in the next step. What angle corresponds with B? E. And what angle corresponds with C? F. Now we need to make sure that at least 2 of them are congruent. I know that angle B and E are congruent because they're both 90 degrees. I just need to prove either A and D are congruent or C and F are congruent. So just pick one of the triangles. Maybe I'll pick this one and you guys can pick that one. And figure out what that missing angle is. All right, we know triangles add up to 180 degrees. So I'm just going to take 180 minus that 90 degree minus that 48 degree. And I get 42 for my missing degree. Does that match angle F? Yes, because angle F is labeled as that. So there we go. We have at least 2 corresponding angles that are congruent. I can solve for the other one, but I don't really have to. because I already have enough information with just those two to prove that they're similar. All right, take like 30 seconds, maybe a minute, and figure out if the bottom two are similar. All right, I've heard one answer. What does everyone else think? Similar or not? All right, so what are my corresponding angles? What angle does A correspond with? Which one does it correspond with? You said F. A doesn't correspond with any of them. All right, well, let's figure out, maybe it'll help, because it is hard to see the orientation of the two triangles. So let's figure out what this missing angle is. What did you guys get? All right, good, that is correct. It is 79. And then for this other triangle, what did you get for the missing angle? All right, and that's correct as well. Hold on 1 second. I don't know if this is important or not. Hello. With 46 being the same on both of them. But again, they have no corresponding angles because they are not similar. You can even try imagining it, turning it to be in the same orientation, and they just don't add up. All right, so this would be not similar. Questions, comments? All right, on the next slide, it's really small on your paper, so let me see if I can just summarize the important part of it. And you can see it blown up on my screen. And we talked about things like scale factor before. So that would play into scale models, making a blueprint of maybe like this classroom. All right, obviously the blueprint's going to be much smaller than the actual classroom. And the way that those work, so like down here we have a floor plan of a kitchen, is that they usually have a scale factor like this, like 1 square equals 6 inches, which would mean that the dimensions of the scale drawing are half the size of the objects in the actual kitchen. All right, so this is just an example. So if the real refrigerator measures 4 by 5, okay, so the real refrigerator measures 4 by 5. In our scale model, maybe we'll do times 6 to make that equivalent. All right, so 24 by 30. Questions about that? So it's kind of like a dilation. All right, just now using it in the real world. You have a couple questions here. These are repeats of the questions that are a little bit above. So if the angle formed by the corner of the dishwasher measures 38 degrees on the drawing, how many degrees would the triangle in the actual kitchen measure if the two triangles are similar? All right, so all right, corresponding triangles have the same or different angle measures if they're similar. All right, look back to one of the first few slides. Do similar triangles have the same or different angle measures? They have the same angle measures. So if this corner is 38 degrees on the drawing, what would it be on the actual kitchen? What do you think? All right, exactly, it should be the same, right? Because corresponding angles are congruent. The other question, how many corresponding angles would need to be congruent in order to determine if two triangles are similar? So what's the minimum amount? There's only 3. So do I need just 1, do I need 2, or do I need all 3? Good, you just need at least 2 to prove that they are similar. You need all 3 to prove that they're congruent. But for similar, you just need, well, not all 3 to prove that they're congruent. I take it back. So to prove that they're similar, you need at least 2. If you have the third, great, but you only need 2. Questions? All right, so we're going to kind of blow through these next 2 practices so that you can do your worksheet. So practice 1, a tortilla chip company hired a manufacturer to design its latest product, Churritos. A bag of Churritos should hold 2 types of chips, large and small, in the shape of similar triangles. So again, similar triangles have 2 things going on. All right, what would we say about their angle measures? Angle measures are the same. Their side lengths will be different, but that's a given in this drawing. So, if these are my images, you are going to be explaining whether or not the chips are similar. And instead of giving you time to do that on your own paper, we'll do it together. And then if they are not similar, what would the manufacturer need to change in order for the chips to be similar? All right, so if I were to figure out the missing angle on the first triangle, what would that missing angle be? All right, do we know how to find that missing angle? So when you have the 2 other angles, just take 180 minus whatever the 2 other angles equal. So angle C should be 50, good. Now, I don't know all the angles for this one yet, but you can see, are they similar or are they not similar? All right, I can see that they are not similar because the corresponding angles, C and F are corresponding angles, and they are not congruent. All right, which would mean I don't even know what D and E equal, but they're supposed to have the same angle measures, and those are different. Questions about that? And that answers part of the question. The other part is if they are not similar, what would the manufacturer need to change in order for the chips to be similar? So let's say this chip is perfectly fine. What would the other chip need to look like? What should angle E measure? Are you guys just not understanding? Are you just too shy? If these are supposed to be similar triangles, what should angle E measure? If they're supposed to have the same angle measures, 38, what should angle D measure? 92, and then angle F should measure 50. All right, don't overthink it. If they do not have the same, even if just one of them is off, then they are not similar. Questions? All right, practice 2. So another real world application. We have an engineer constructed 2 similar triangles to support a bridge shown in the figure. BRI, so the smaller triangle, so it's red BRI, is similar to IDG. All right, so this order shows me what angles correspond with each other. I don't even have to figure it out from the drawing because it told me in writing. So what angle does B correspond with on the other triangle? I, good. I'm just going to kind of highlight it. Notice I is labeled twice, so it's referring to the bigger triangle. R corresponds with what? D and I corresponds with. All right, so it looks like that. I know I is listed twice, but that is explained to you in the way that it's written out. Make sense? All right. Tells you other stuff about the side lengths. We know the side lengths will be different, but they'll be proportional to each other. If angle R measures 98 degrees, so angle R measures 98 degrees, and angle G measures 41 degrees, what other information about the angles can we conclude from the diagram? All right, so basically let's try labeling these other angles just with the information it gave us in here. All right, so anything that we add, I'll put in blue. So like what's something that I can fill in given this information? This one here, good, and because remember there's 2 angle eyes. So what does the BIR angle mean, or will it be? 41, good. What else can I figure out? Which one? I can figure out angle D from what's labeled, because this should match its corresponding angle. So what should D be? 98, good. Am I able to somehow figure out this yellow one? Yes, I can do I forget what theorem it's called, but it's the one that says triangles add up to 180 degrees. So 180 minus the 2 known angles, minus 98 minus 41. What angle will angle B measure to? 41. And so we can figure out all the other information just from knowing that the triangles are similar and from having like two random angles listed for us, labeled for us. Does that make sense? Any questions? Alrighty then.